Hello there, Cardinals. It's me, Mr. Ernst, and today we're going to be talking about congruence once again, but this time we're going to talk about reflections. So once again, we are talking about congruent shapes, making congruent shapes through reflections. And the first one we're going to take a look at is nature's reflection on this beautiful little butterfly. So let's start off by me grabbing a point up at the tip of this butterfly's wing here, and then kind of bringing this over here. So we got one. Hold on, wait a sec. Let me get a little better spot here. 1 to 1. Okay. So we can see this wing is a little bit longer than this one, but that's okay. I'm going to grab this spot down here as well. Let's grab this little tiny spot just underneath where it kind of attaches to the body. And then finally, right down here at the bottom of the wings. Okay. So what I want you to notice is that we have this line of symmetry coming down through our butterfly. And each one of these, we have one point on one side and the same point on the other side. Now, if I get rid of this butterfly, you're going to notice that this is a very symmetrical looking shape, which is kind of cool. And why that happens is because this point on the butterfly is the same distance to the line of symmetry as this point over here. This point has the same distance to the line of symmetry as this point and this point, this point, and this point. Okay? So for example, if this was a distance of 5, then this would also be a distance of 5. This would be a distance of 3. This would be a distance of 3. If this was a distance of 1, this would be a distance of 1. If this was a distance of 2, this would be a distance of 2. All of these points and their pairs are the same distance from the line of symmetry. And that's where this butterfly gets all of its beautiful symmetry from. And that's a very key thing to remember as we go in to look at actual shapes themselves. So, first one we're going to take a look at. Here is another beautiful right triangle, same kind of one we were looking at last time. And a reflection requires an extra piece that the translation did not. The reflection requires what is called a line of symmetry. And what that line means is that I'm going to be able to take this shape over here, and this would be a translation. It's just sliding from one side to the other, but a reflection causes this shape to actually flip. Causes the shape to flip from one side to another. So a translation was a slide, a reflection is a flip, and I want you guys to remember that it is a flip, okay? I like to think of it kind of like a burger patty. Like SpongeBob's putting his little spatula up underneath this, and he's flipping it from one side to the other. It is getting flipped like a pancake or a cheeseburger, whatever you feel like. So, notice, just like the butterfly, when I'm looking at this, the distance A has to this line of symmetry here is the same distance that this A here has. So again, if this was a distance of 10, this would be a distance of 10. They both have, oh, by the way, these is A prime, B prime, and C prime here, because it is the after image. B is the same distance to the line of symmetry as B prime is. And then finally, C has the same distance to the line of symmetry as C prime does. They all have these beautiful little parallel lines that connect them back and forth, okay? And that is a key thing about reflection, that if A is 10 away from here, A prime must also be 10 away from here. So let's take a look at what this looks like on a graph. All right, so looking at this on a graph, reflect the shape over the y-axis. Now, the y-axis, as we all know, is this nice bold line down the center. So this is going to flip over here, and it's going to end up somewhere over here. So we're reflecting or flipping it from one side to the other. Now, this is very simple because just like the thing, we're going to go one, just like translation, we are going to go just 1 point at a time. Every single year I have taught this, I have people who try to come over here and try and sketch out what they think the shape is going to look like. And every time they try to go through and do it, no matter how good of an artist they are, they always end up messing it up, okay? And I know this is messed up because, look, D has a distance of 3 here and only 2 here, so I've already messed it up. And I've been doing this for years. So, only 1 point at a time. Let's start with A. We're going to count how far A is from the line of symmetry because its reflection, A prime, needs to be that same distance. So A is 1, 2, 3, 4. a distance of 4 from the line of symmetry, which means A prime also needs to be 1, 2, 3, 4 from the line of symmetry. So right here is A prime. Same thing with D. D is 1, 2, 3 away from the line of symmetry, which means D prime needs to also be 1, 2, 3 away from the line of symmetry. So now this is going to be D prime. B is 1, 2, 3, 4, 5 away from the line of symmetry, which means B prime needs to be 1, 2, 3, 4, 5 away from the line of symmetry. B prime. Finally, C. C is once just like D, C is 3 away. And so C prime must also be 3 away. So C prime would be right here. Now this might not look like it's doing this properly or it's not reflecting properly, but if you let me connect the dots here, boop, 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 you can see this has created a perfect flipped shape. Starting on this side, it has gone woo and landed over here. I also want you to notice that D starts on the right side over here, but after the reflection, D and C are both on the left side of the shape. Cool? So if I was to erase all these lines in the center here, you would see that these shapes are perfectly reflected from one side to the other. Reflections are all about, the distance from the line of symmetry to the shapes themselves. Our last example we're going to look at, what if we need to reflect over the, I forgot to change this. What if instead of reflecting over the y-axis, we have to reflect over the x-axis, which is this line right here? Now this looks like it's going to be a little bit tricky because look, we have B, A, and D on the top side of this reflective line, but then we've got C hanging out on the bottom side. The rules of this are exactly the same as beforehand. We just need to make sure we are tracing over to the other side. For example, B has a distance of 1 to the line of symmetry, so B prime has to have a distance of 1 from the line of symmetry, B prime. A has a distance of 1, 2, 3 from the line of symmetry, 1, 2, 3 from the line of symmetry. Here's A prime. D is going to be 1, 2 from the line of symmetry, so D needs to be 1, 2 from the line of symmetry. D prime. Our last one is C, and because C is on the bottom, it's actually going to be going to the top side this time. C is 1 away from the line of symmetry, which means C prime must also be 1 away from the line of symmetry. So here is C prime. Once again, it's kind of hard to see because a lot of this stuff is kind of overlapping. So I'm going to see if I can erase some of these orange lines real quick so I can show you exactly what this looks like when this is kind of flipped here. Okay, so we got the orange lines out of the way. Now, once again, if I connect each one of these, C to B to A to D back to C prime, boop, you can see that the original shape has officially reflected over the x-axis from here down to here. From here down to here. Cool? And that is it. That is how you reflect a shape. Thanks for watching.